So we're back. Okay. So I'm going to be showing V-Ray for Modo first, followed by V-Ray for NUKE. This year we actually announced both of those products, or both of those versions of V-Ray for the two platforms at SIGGRAPH. So I'd like to say first that they're still in beta phase. Actually, they are in open beta, so you can go ahead and try it yourselves, download it from our website. So I encourage you to do this, because we really rely on your feedback in order to make the products better and better. I'm going to start with one of the really good features, really great features that I think make V-Ray what it is. And this actually is the V-Ray RT. Before that, however, I'm just going to take a look at where you can find V-Ray in the interface of Modo. After you install that, you will see a new V-Ray menu, which gives the basic options like render with V-Ray, render animation, start V-Ray RT, and a couple of other additional features like the V-Ray toolbox, for example, which is really convenient one because it will pop up and give you also the same features that the V-Ray menu gives, and they will be easier to access. It also gives a couple of other options like the V-Ray preferences, which actually will open the Modo preferences at the V-Ray tab sections. So here there are a couple of options like for the ones for distributed rendering, and the immediate camera update, which I'm going to explain in just a couple of seconds. So also it gives you access to adding geometry properties and physical camera, and currently these are the settings here. So I have, let's take a look at the scene. I have a watch with a basic light setup, kind of a studio one. So if I want to take a look at what this looks like really quickly, I can start the RT CPU, and in just a couple of seconds we have to export the scene. This is my old render. Yeah, you can see the watch being rendered in real time. So whatever I do in the viewport is being reflected in the render. We have to render, I'm using the V-Ray frame buffer, and there is a really good reason for that, because it allows me to do something like color corrections on the fly. I'm going to show this in just a couple of seconds. But the most important thing here is that you can see that whatever I do is being reflected in the render as I speak. So if I want, for example, to go and change one of the lights here, I can go and take a look at the shaders of the lights in Modo. So let's take a look at the front light, or the top light, and take a look at the light material, and change its color to, let's say, I don't know, something more colorful, something like this red color or this pink color, and you can see that immediately in the viewport. So you can literally experiment while rendering and do your look development as we go. Now, as you can see, since this model requires lots of reflections, even after a couple of seconds, the images is kind of noisy. Well, I have plugged in bump noise on that, so there is a noise on that, but also the quality is a little bit compromised. So what I can do here is use the track mouse while rendering function, and if I zoom a little bit, give it a couple of passes, a couple of seconds, you will see that only where my mouse is, this is where the rendering is going actually, and the rest of the image is not being rendered. So if I place my mouse here, this is where the samples are going to be. So this is a great way for you to focus your processing power. Well, for example, here I'm using a laptop, which is not that powerful, and I'm only concentrating the computational power in only the parts of the image that I want to. And I like to call this a magic wand, or which is placing my samples everywhere I want to. And if I turn this off, the whole image is going to be rendered once more. It's not going to be reset. Also, if I decide that this is not the point of view that I like, I can quickly readjust that. And let's take a look at, I don't know, let's just really quickly switch to wireframe and take a look at, okay, the active mesh should be in wireframe. I can't seem to find it. Anyway, if we take a look at the shaders here, and if I find this one, the red one, I can take a look at its settings, and it's a V-Ray material, and change that color to something else. Yep. I believe I did not find the correct one. Anyway, let's select this thing here and take a look at its own shader and make some adjustments to that. So it has the shader of glossy metal, it has a bump slot on that. So let's change the color of that to, I don't know, something not that green, more of a blue. And you can see that you're not limited only to changing lights and camera position. You can play around with every colors with all the shaders. You can change the bump, the displacement, or whatever you need to, reflections, refractions, and this is going to be reflected immediately in the viewport. So you can see immediately where this is going and or if you like this or not. So this is why I think V-Ray RT is one of the greatest features in V-Ray, because it gives you immediate feedback and interactivity at a really, really great extent. If I open up the color corrections window here, or the color corrections panel, you will see some basic color corrections that you can apply right as you're rendering. So for example, I can just enable the exposure and adjust the exposure in real time. Actually, this is a post-process that is, since the V-Ray frame buffer is in full float 32-bit, it keeps the high dynamic information, so you can change the exposure even in post. Also, you have contrast. You can change the white balance later on if you forgot to do that with the physical camera, or you can adjust the hue and saturation, make some experiments with that, and make decisions right there, right inside of the rendering while it is going on. So this will save you a couple of steps in order for you to, like for example, to save the image, go into Photoshop or NUKE or whatever is your favorite compositing program, and do the corrections there. So for just simple things like this, you can do all of these right over here. Also curves. And for example, if I make some curve, like for example a basic contrast curve, something like that, or with some more points, if I like that, I can save it from here and then load it up as a preset later on. Or if I like all the settings here from the color corrections window, I can save a global preset and load it later, or share it with a friend or a colleague, and so on. An interesting thing about the color corrections window is that it allows you to plug in a different image as a background. So for example, if I plug in this texture, it's based on the alpha that I have, I can see, this is really, again, really simple thing, but it allows you to see your rendering in context without having to create, to put it in the render. And I can clear that if I want to. Also, we support LUT tables and open color input-output profiles, which can be generated in a compositing program so that you can see what the final grading is going to look like in the moment of the rendering, right in the viewport. Excuse me. Also, one really interesting feature of the V-Ray frame buffer is the function that it allows you to save images. So I can save, and it will show me some basic information like the resolution and how much time it has been rendered. I can type in some comment, for example, I don't know, blue 01, some comment that will make sense for me, and it will be pop up here. Then I can rotate, do some other point of view, wait for it to render or not, save it once more, and then I can do some comparisons between the two, or just switch between one or the other by using the keys on the keyboard, 1 or 2, such as the number suggests here. So I'm going to stop that and move on. One last thing that I forgot to mention about the RT is that since the RT is a progressive render, progressive ray tracer, it will continuously refine the image as you saw, and you don't have to think about any of the settings, of the technical settings in V-Ray. You don't have to adjust subdivisions of the materials, subdivisions of lights, or whatever. What you need to think about is only the colors and the positions of lights, the colors of your materials, the amount of reflectivity, and mostly the artistic stuff that you need to do, what texture you should apply. This is what we meant by introducing and making the RT, to leave more freedom to you, and you can make more iterations and quickly reach the result that you want to. let's take it something else. Again, I'm going to be using the V-Ray RT. And let's close the other scene. Don't want to occupy memory. Okay, so here I have a pretty detailed model sculptured in ZBrush of an alien. So since this is a character, I wanted to give it a subsurface shader. So the subsurface shader in V-Ray was up to this version of V-Ray, the 3.0, actually up to now, was dependent on a prepass. So you had to make a prepass first and then render everything else after that. So actually this didn't make sense. Didn't make sense in the context of interactivity. So in order for that to work with RT, we actually introduced a new version of the subsurface scattering shader, and it doesn't require prepass. Because imagine every time you turn around the camera or change something, you wait for a prepass for the whole image to be calculated and then start rendering. This is just tedious, and we didn't want it to wait. So I'm going to demonstrate that feature now. I'm going to run the RT. So as you can see, there is absolutely no subsurface scattering, and this is because I'm using the prepass based solution. So if I select my model here, take a look at the shader and in the properties, here you'll see that I'm using the prepass based illumination map. So if I used to render, actually let me show you the rendering with the prepass based illumination map. This is the prepass that I'm talking about, and after that you can see the subsurface scattering going on, and I can stop that. However, if I run the RT once more, and you will see no subsurface going on, I can just switch to the ray traced mode of the subsurface scattering, and you will see the ray tracing of the subsurface scatter immediately. Again, I can use the brush and just take a look at the refined parts only on the ear. And this is particularly useful, especially for such kind of shaders where you have to see the translucent effect of light passing through, but not clearly. So this is very important, important shader for character artists. Of course, everything is interactive, as I showed you before. Let's change the scattering radius, the scattering color to something green, because in my mind aliens are green. So let's make it a little bit greenish, and probably they might have a blue color of the skin. So let's make it. At least this is much more believable in my mind. So this is alien to me. Of course, you can rotate, find a better point of view. And yeah, and the only thing that you need to do now is just wait for it to refine and decide if this is the rendering that you're looking for. If not, just continue tweaking. So let's stop that thing. Actually, I forgot one thing I wanted to mention. I'm going to run one last time the RT. I can actually change the shader because since V-Ray has a user-driven development, we always try to listen to our users, and one of their requests was to make the subsurface scatter a bit more user-friendly, meaning that if you want to make a character, you might need a bit more control, such as more subsurface scattering layers and more reflection layers, because currently it has only one. So this is why we created a new shader, and that's the V-Ray skin material. It's located over here. So the moment I change that, you should be able to see it in the viewport. Let's refresh it. okay, and it's still and it's currently set with using the prepassed illumination map. So let's switch it to ray traced. And now you can see again we see the subsurface going on. However, what's more important here is that you have much more layers now. We have shallow color, we have medium color, and deep color. All of them have radiuses that you can change. So, for example, let's make it more obvious. So the shallow color should be green again, my favorite, and the deep color is red. Okay, so if I focus, let's remove actually the medium one because it's a bit easier to understand. So now wherever I have a front lightning or lightning behind there is lightning behind my camera, a light behind my camera, I can see more of the front color. So the shallow color actually is the really thin epidermis of the skin. So that goes there. This is where it goes. And the deep color is this red thing, which I'm allowing it to go further deep since my radius is 2 units. If I make it 10, for example, now the whole thing is going to become red, more red, since I'm allowing this this red color to go further deep into my object. And actually this red color is generated by a light which is behind the object. And you have also a couple of specular layers, primary and secondary reflection layers. They trace real reflections by default, and the diffuse layer, of course. Okay, so as you can see, it's much more flexible. Let's have a look at something else. Here is a hair example, and to be honest, this is not a pure hair example because I wanted to show you a couple of things. So currently I'm using V-Ray proxy in order to import alembic hair, which was exported from external application. So what I want to show you is that first of all, the V-Ray proxy now supports alembic format, so you can import not only geometry that is animated, you can import particles and, in our case, hair. So this is hair, and I'm going to render that really quickly. Oops, I wanted to render it with the production render. So right after a couple of seconds, you will see the GI being calculated, and I want to remove that out of the way. So yeah, this is here in Modo, using the V-Ray proxy, which is, I think it's really awesome. What's interesting here is that this object actually consists of not tubes like regular hair would be, but is being generated as thin stripes. And these thin stripes, in order to look correct as a real hair, they are exported as thin stripes because we want to save geometry. We don't want to export that many polygons. So in order to look correct, it has to have a special shading. So that special shading is the V-Ray hair material. And let's not waste time. I'm going to take a look at the shader really quickly. So that's a proxy here, and that's a V-Ray hair material. The important thing about that shader is that it supports 2 specular layers, because the hair tends to have 2 specular layers, and it allows for transmission of light. Because hair is very thin and it tends to allow light to pass through it, and this is why I have set up this light right here behind so that we can see the translucency going into effect. Okay, so let's get rid of that. Take a look at something else. Really quickly, I'm going to show you V-Ray has a native PTX support, which is something really cool since Modo doesn't have PTX support. So if you want to utilize, so this is our van before it has any PTX applied on that, and I have this. Just a second. I have this thing as a PTX. I'm going to unhide it. Oops. So now I'm just going to render. And it's going to take just a little bit more time in order to load the PTX. But if you don't want to unwrap your models and just use the PTX functionality, you can do so since, as I said, Modo doesn't support PTX out of the box. So I think that's cool. We try not to limit. Oops. And we try to extend the functionality of to as much as we can. Let's take a look at the displacement really quickly. So here, from this column, let's render. So yeah, so this is the original render. However, here I have applied a vector displacement on that. So if I select that and apply, oh, sorry, not that. And apply the state material, re-render. I get to that. So this is only by using one texture and the V-Ray vector displacement, or the displacement set up in vector mode. The vector displacement is a special kind of displacement which allows for geometry to be concave, and so you can have geometry overlapping another piece of geometry using the vector displacement maps, and you can generate these in ZBrush or in Maya. In Mudbox, and utilize this one here as well. Also, you can animate the displacement, and by the way, let's take a look at some other examples. Oops. Just really quickly. So, for example, from this, you can go to this. Again, just using one vector displacement map. And of course, you have to generate this first and to scope all of this, but it's pretty awesome. Let's take a look at something else. And I think that would be the last thing for Modo for today, since I don't have that much time. So let's take a look at replicators. So it's a relatively new thing in Modo. So you can scatter objects as many times as you want. So I decided to make my own fleet of airplanes. So here is the original one. It has animation. Let's initiate the RT. Let's remove that thing. Okay. So that's the object. Let's zoom out, and I here have the replicators. Let's enable them. Give it a couple of seconds to load up. And here they are in the scene, and we should see them in just a couple of seconds. Oops. It's a bit sluggish, but I'm rendering and I have a couple of thousands of polys in the viewport, so my graphics card is just a little bit not holding up. Anyway, here is my fleet. Also, I can unhide a ground object so that I have some shadows on the ground, but this is not that naturally looking, so I'll have to assign a texture as well. And here is my, oops, not this one, this one. Okay, so here is my ground, and I'm using just a simple texture of a ground, a photo actually, so that I can use it as a shadow catcher, and I have my fleet in context really quickly and really easy. So if I want more planes, I can adjust the replicator, and I can see that again in real time in the viewport. Also, if I select the replicator node, most of you well know that you can just change the parameters and rotation, scale, position, and so on and so forth. So you can utilize this one as well. Also, you can assign random textures based on the ID of the particles, or the instance. So this is also supported. And I think this was half of my presentation. How many people were interested in the Modo part here? Did you like what you saw? Okay. I hope you're going to use that. It's, as I said, it's in open beta, so go ahead, download it, and try it for yourself. And be sure to tell us what you think. Okay, so let's take a look at the Modo, the NUKE part. So give it a quick start. Oops. That was interesting. Okay. All right. So yeah. So how many of you are familiar with NUKE? And okay, most of you guys. So how many of you know how to set up the regular scanline render in NUKE? Okay, so for the rest of you, I'm just really quickly going to run through the basics, and then I'm going to show you some kind of production examples. When you install V-Ray, you will find it right over here, and it's split in three categories. The first one is the most important one related to the rendering. So the first one, the first node is V-Ray render. I'm going to create a one render. Plug it in here. So it has three inputs: background, object scene, and camera. In order for you, we have these settings which are turning on the anti-aliasing. We currently support only the adaptive DMC image sampler, and we have global illumination. Only brute force is supported for the moment. We have a couple of other options. I'm not going to discuss these currently. So the other thing that you need to do is you have to have V-Ray background, and that's a special type of background. It's not just a color, and this goes into the V-Ray background. Now, there is a perfectly good reason for this, and this is because in V-Ray you can have separate backgrounds for what the camera sees, for a separate background for the GI, for the reflection, and for the refraction. So you have to have slots for these. And also they can be mapped in using different projections, like the ones that you see here. Also, I'm going to create a constant for a background. I'm going to set up my project to something really small, and I'm going to plug this in as a background. Now, this is the way I define my final output resolution, by hooking up a background constant in the background. Then what I need is a camera, and we can use the camera from NUKE. V-Ray also supports V-Ray camera, which actually gives you just a couple of more projection nodes, and it's an extension of the V-Ray of the regular NUKE camera. So I'm going to use just the regular NUKE camera, hook that up. And also I need some object to render, right? And also I need some light to illuminate that object. So in order to put both of these things together, I will create a scene node. Sorry. Okay. Going to plug that in, then create a simple sphere from NUKE, plug that in here, and actually let me show you all the lights that V-Ray supports. Now, V-Ray for NUKE, V-Ray light dome, ambient light sphere, rectangular, IES for IES profiles, and light mesh. Now let's create a sphere light and hook that up as well. I'm going to create another viewer so that we can see and switch to another. Okay, the first one, the second one, and I'm going to use the other one, the second one, as a 3D viewer so that I can see what's going on in my scene. Now, if I take a look at the render, it doesn't seem like much. So what's the reason? Well, because everything is in the center of my scene. So I have to move the camera a little bit out of the way, and then I have to move the light a little bit away. So everything is overlapping. But as soon as I change this, you can see we have a rendering going on. I can change the color of the light. I can change the intensity if I want to, position and everything. Now, how do we apply shaders? Well, that's really easy. The shaders that currently are supported are V-Ray material. The next two are for the V-Ray blend material. We have material wrapper and material bump. The other ones are a bit more specific. So I'm going to use V-Ray material and hook that up for the sphere. Now it has some shader applied on that, and I'm going to give it some reflection, make it a bit glossy, and so that we can see something, I'm going to assign a checkerboard for my reflection environment. And now we have reflection. Some Fresnel. So we have physically based ray traced reflection inside of NUKE, something that wasn't previously possible. And that's the basics. You can assign textures in here, and you have a couple of other additional slots that are going to be revealed as you plug in more textures. You can also assign textures to some of the lights. For example, the rectangular light. It has a texture and an axis node, and the axis node is useful if you want to, for example, import something using an FBX, and NUKE will generate axis nodes for the lights so that you can link the input of this light to the axis node that was generated upon an import, and then you can replicate the behavior, animation, position, everything from the lights that were in the FBX file. And I think these are the basics. One last thing, when you render, one of the most important things about V-Ray are the render elements. So let's take a look at how do we create these. Here's a render element, and you can select a list of render elements that you need. For example, let's take a look at the reflection here, and I have to plug it in the main scene. Now it seems like nothing has changed, but now I have the reflection as a separate render element. I can duplicate that, and if there is something missing from that list, you can always say I want an extra texture, and then I can plug in something like, let's take a look at some additional. Here we have sampler info, and the sampler info can give me some more utility passes like camera normals or point position pass and so on and so forth. Let's take a look at the point position pass, plug that in, and plug this into the main scene. Now if I take a look, I'll have extra render something, and I have the point position pass available. Okay, let's close that and move into more interesting stuff. Come on. Okay. Now, I think I have it in the recent files. Okay. Switch to my other viewport layout. So this is my 2D viewport. This would be my 3D viewport, move it around. Okay, so I'm going to enable that. Here I have, I'm going to show you. I have the ship. Actually, how many of you were yesterday at the workshop? Just a couple of guys. So the same fighter, the same ship, is going to be here. Let me pause the render. I'm going to use the same geometry here, and I've plugged that into NUKE. So let me do something in order to see the shader, the geometry better. So that's our object. I've grouped everything together for ease of use, and here is everything. I imported all of the geometry, applied shaders, applied textures, and combined everything together. Here, by the way, this is how you use V-Ray light mesh. You plug in the texture that you want to, and you plug in the mesh, and these are the settings, just the regular settings, the one that you're used to. And okay, so I'm going to enable my lights as well. I have a couple, 3 lights actually, and let's enable the rendering. Give it a couple of seconds to load up. Okay, so this is how it looks like. It's really interesting that you can actually, I can, for example, let's disable that light first and take a look at the rendering without my top light. So this is how it looks like. It's a little bit harsh, so I'm going to bring it back. And I can change the color of that light if I want to. So for example, to a little bit cold, or not a little bit, but more cold. Even colder, okay. Then I can, for example, increase the intensity of that thing. Give it a second. Remember, I'm rendering on a laptop, so it's a little bit slow. Okay, let's make this a little bit purplish. And bring back this intensity. Okay, so by using a simple shader or a simple diffuse material, I can see how my lighting goes, and I can make kind of light development right here. It's a little bit slower than you would do it with the RT, but the really cool part is that you gain all the goodies that you either weren't available, like reflections. I can change, for example, the glossiness to make the reflections blurrier. And now I can see, I can make it even more glossier. But what I see here is that I do have some noise. So I can fix that really easy by going into my render and lower the noise value. It will take a little bit more time to render, but it will be cleaner. Okay, so what else? I have here a small noise background, which will generate some sparkles or stars. Now, actually, let's show the thing with the final materials. Give it a second to load up the textures. By the way, I'm using three 4K textures, which are, well, I'm resizing to 2K, but anyway, NUKE has to read them, combine them together, and yeah, it will take a little bit more time to load the first time. So if we take a look at what's going on, here are my textures, and you can see what's going on in here. Constantly reading here and there. So actually V-Ray is waiting for NUKE to calculate the textures and then load them up. and it becomes something like a loop. But anyway, it's still in early development, and we will address these things for sure. Probably, I think we're wasting time, so or probably something happened. So I'm going to pause that and take a look at the final result. So after I finished everything and I saw the final result, I plugged it in and rendered it out. So that's my final result in here. So this is with just textures applied. Let's increase the resolution, and I have an animation out of that for just rotating the ship. So I wanted to make use of the fact that I'm rendering inside of NUKE, so that I have the 2D and the 3D at my disposal. So a cool trick that I actually thought of was I wanted to pimp this up a little bit and plug in a couple of flares onto the engines. However, there are two things about this. The engines are moving, and sometimes they're facing the camera, sometimes not. So I wanted to make it more automated. So what I did was I created a couple of axis nodes in NUKE, which I placed exactly on the locations where the flare I want to be. So here, here, and here on the three engines. Then I ran reconcile nodes on these, right over here. And the reconcile node in NUKE actually takes a 3D position and bakes it from the camera perspective into a 2D key. So it generates the 2D position of the tracker, let's say, inside of the viewport. So then I used this one to drive my flare. So this is what happens. Let's pause this one. I don't want to slow down the rendering. So here I have a little bit of scripted flare, but it actually follows the position of my engine. However, as I told you, sometimes the camera faces, actually the engines face the camera, sometimes not. So I wanted to automate this once more. By the way, the reconcile node works just by plugging the appropriate nodes and then say create keyframes, and this is automatically done for you. Then I used multimate render element, which I set up earlier here in the render. So when I render that, let's take a look at what it looks like. So this is my multimate render element, and the one that I'm more interested in is the red parts here, the engine lights actually. So I extracted these. Take a look at that here, shuffle them, blur them a little bit, increase the values. And then I used another node in NUKE, which is called curve tool, and it can be set to analyze your picture or a region of your image and take a look at some values in the intensity of certain channels or average intensities. In my case, I used what is the maximum value of this small region here. And this region here is actually 1 pixel, which was driven again by the information that I got from the reconcile node. So I just hooked that up here, and then I created this one to be the other one plus 1. So this means 1 square area. So in this position, I'm analyzing the maximum amount of luminosity here, and then I'm using the same thing into a grade node to control my gain. So the result of that was something like this. Yeah, okay. So now by running one automated process, really easy, I can safely change the position of my engine and just really quickly adjust this, because I have the multimate from V-Ray, which is showing me when the engines are facing away and towards the camera, and I have the 3D inside of NUKE, so I can reposition that in context and on the 3D itself. So doing this for the 3 and combining it with a little bit of glitter gives me that final result. And a little bit of texture on the flare because you can never go wrong with the texture on the flare. And you have something like that, which is completely automated, and whenever I need to do some change in my render, I just re-render that, run the reconcile node, and I get it for free. Okay, so let's take a look at something else. I do believe we have 5 minutes more. This one. Oh, no. Let's close this one. We don't need it. Okay, so here is the same setup. Let's show everything in one go. Go into my other layout. And take it a couple of. Give it a couple of seconds to load up. Here I'm using a robot which has been imported using Alembic, and it has animation. However, I didn't render the animation, but what I did was, okay, so here's my rendering. By the way, let's pause that again to take a look at the scene in 3D. Okay, so here is my robot, courtesy of Robert Netherhost. It's an asset from his short movie Archetype. So if I scrub the animation, and it takes a little bit of time to load since it has a little bit of poly count. So you can see, and the robot jumps away in the distance towards the sky. For the future, no one knows. So I have positioned a couple of lights here, and let's render. So zoom out a little bit. Take a look at the. So here, again, I have the whole robot into one group. Then I have a platform here below the feet of the robot. Excuse me, and I have lights group, which actually has all the lights turned on. Now I have a dome light and a couple of lights here, mesh lights actually, not mesh lights but sphere lights for the robot parts here, which you can see dark. And then I have a studio setup in that case. Because I'm lazy, I expose the controls of most of the lights into one node using the manage user knobs functionality of NUKE. And I have, for example, I can turn on the dome light, and using an HDR, give it a little bit of time to load up the HDR. Now I have an image-based lighting inside of NUKE. So if I go and rotate the image by almost 180 degrees, excuse me, I'm changing the lighting conditions and the shadows and everything. Also, let's turn off the dome light and show the studio lights one by one. Okay, so come on. Let's turn them all then. Okay, so here are a couple of the lights, and then I have top light, and then a small fill light here at the feet. Okay, so I also have exposed control over these lights, and I can change the controls, which are going. These controls are going to change the lights inside of the group. Moving on, I have a couple of shaders applied here, and I made a material switch so that I can show these a bit faster. So when I go to the first material, we will see a bit more reflective shader. I'm using this as a material preset. I've configured this earlier, so that's the reflective one. So here I'm going to show a textured version of the robot with the texture applied in the diffuse slot. looks kind of like a bumblebee. And then I can show you here blend material, which is actually here I have a couple of blend materials, and the textures are around 7K, so it might take a little bit of time to render or to load. Okay, so if you see here, I have dirt on top of that, so I have a couple of rust blend shaders on top of that. Of course, there is no anti-aliasing. Let's turn on the anti-aliasing as a final thing before I show you the NUKE part. So if I render that, okay, so now we have anti-aliasing and you can see it a bit better. So yeah, some rust and some over some paint, or the other way around, and everything goes in here. Anyway, I rendered the whole thing later on. Here are my all the render passes that I extracted here and rendered them as well. So here's my final result, and I selected the clean version because I like it better. Let's get rid of that actually, or pause that for a second and move this out of the way. Okay, I wanted to see it good. All right. Okay, so what I did here, actually I'm going to need a little bit more space. I didn't render the animation, but however, as I told you, I rendered a couple of nodes, a couple of render elements here, like the diffuse, some UV maps, and so on and so forth, so self-illumination. Anyway, and here I have also some additional passes like the point position pass and camera normals pass. So what I did here was I wanted to again to make use using the same functionality. I wanted to make this use because I'm rendering inside of NUKE and I have the 3D model at my disposal. So what actually was more interesting is I wanted to make something like a force shield. So let's see how I did that. If I impose that viewer, I created an axis node which I can position really easy inside of the 3D viewport here, and then I created another one and position that here. But I can change the position. I can change the position very easy wherever I want to. Then I used that to generate a p-mate. Do you know how many guys know what a position mate is? P-mate. Okay, so I'm just going to explain a little bit. Since this is a 2D trick, since I have exported the point position pass out of V-Ray, and the point position pass means each pixel has a RGB value of X, Y, and Z where it was located in world space units. So 1 meter away by the x-axis and 2 meters by the y-axis, and so on and so forth. So I'm using that point position pass to take a look at where my position of where is my axis in 3D, and generate. Let me show you, and generate black and white map in the alpha channel, or let's take a look at that one. Black and white map, which is telling me which, or actually measuring the distance between the axis node and each pixel based on the point position pass. So whenever I move this thing, I have actually like a spherical selection of pixels. But this is actually something that NUKE calculates on the fly because it has information about these pixels where they were in 3D. Also, and this is done by expression nodes. You can take a look at the mathematics. It's really simple. You just take the square root of, well, this is actually Pythagoras, or I'm not really sure. It's a vector. Yeah, actually, I have another control here which says what would be the distance away from that point, so I can make change in the selection radius. So that's interesting. However, what's more interesting is that from the camera normals pass here. Yeah, not that one. I'm going to keep that in 3D. Sorry about that. Okay, keep this in 3D. Take a look at this one here. So, right. So from the camera normals pass here, I'm not looking at it correctly. I'm inverting that and grading it a little bit and taking the blue channel. And because this is a camera normals pass, the blue channel says how much the faces are facing, the polygons are facing the camera and how much are facing away from the camera, which is actually looking something like that, like a Fresnel or facing ratio from the sampler info in Maya. Then I kick it up a notch, I gave it some coloration and quite some intensity. And then I'm using the point position masks, which I already pre-multiplied with some noise, like that, in order to give it some more randomness. And then becomes pretty standard NUKE thing, a little bit of glow. Here I'm using a little bit of glint, and actually, by the way, the glint here looks like that, blur it a little bit, grade. And then I shuffle in some noise inside of the, well, this is inside of the vector distortion channel. Then I use a distortion map to make it a little bit fizzier, like something like that. Okay. And then combine all of these together to get something like that. And if I take a look at the final result, I got something very similar like this. So the cool thing about this is that I can very easy change the scale to that, and it kind of looks more like a fire. But what's even better is that I can change again the position by selecting this thing. If I move it around, it will change the position of that, and I get all of this for free because I had all of the let me show the animation. I also animated the noise. I get all of this for free because I rendered all the passes with the final render from V-Ray. Also, if anything was missing, I can always go back and re-render that, adjust a little bit the passes, and get a different result. However, this is not like, this doesn't look anything like a force shield, so I wanted to show this one actually. So what I can do here, really quickly, and that would be the final thing, I'm going to change the color of this because in my mind, the force shield is blue. Then it doesn't have that much of a fiery look, so I'm going to lower the length of that just a little bit. Just a little bit of smokiness. And then what I wanted to achieve was the illusion of the force shield being a little bit away from the surface. So I eroded, I took the point position and normal position passes here. We can take a look at these like that, and actually applied an erode to that, which gave me actually that result, as you can see. And these look like actually, let's take a look at that. Oops, this is post. So I eroded these and this one, so it gives me a little bit of push out. And then I have the force shield away from that. And by adjusting the erosion here and here, I can change the effect of how much away from the surface that would be. So just a little bit or a little bit more. And the really cool part about this is, again, I can just take a look at the 3D scene. Okay, but now I have animation, so I didn't render that. Take a look at that first frame, and reposition these axis nodes wherever I want to. So if I want my robot to be shot, for example, in the foot, and change the radius of that to be a little bit less, or in the arm, I can animate this later on in NUKE, and for example, I can animate the axis node coming in front and going behind the robot, and this is going to generate a proper activation of the force shield. So, so I believe this will be all. My time is up. So I think we're going to have the draw now. So, yeah, thank you.